I will find tx, which is 2x minus 8. I will find ty, which is 4y plus 4. And when I set these equal to 0, I will get x equals 2 and y equals -1. Ah, really? Okay. So next. Ah, I just need more paper. Yes. Thank you very much. Very good. So my apologies for that. So now I want to determine txx, which is 2. I need to determine tyy, which is 4, and txy, which luckily txy is 0. So now all I have to do is determine d. So when I get d, I get 2 times 4 minus 0 again, so this is 8. So this implies that 4 comma -1 is a relative min. Because txx is positive. Same situation. Now if I want to determine 4 comma -1, I will find 16 plus 2 plus 8. No. So it's 4, right? 16 and -2. So this is -32, right? And then, yes, and -4. So this is -16, and -2 is -18. Very good. Now let's go back to whatever you think. Yes?
So the last part of that asks, is there a maximum temperature? Is the answer to that there is no relative max, only an absolute max?
So first of all, we found the minimum temperature and where it occurs. So the minimum temperature is -18 Fahrenheit.
Right.
And occurs at 4 comma -1. Okay. And is there a maximum temperature?
No.
And the answer is no, because we only found one point, and that point cannot be maximum and minimum at the same time. That would be a saddle point. So I would have to say no. No max temperature. According to the function.
And would there ever be
A situation in which we have both?
Yes.
Yes.
Have we experienced one of those?
No, we haven't, but I can look in the book and see if there is a possibility to find one with 2 different points. In other words, when you solve the system, you get 2 points.
Okay.
So fx equals 0 and fy equals 0, it will be quadratic.
Test those points.
Yeah, and then you test both points.
Um,
That's the only difference. So we can take a look and see if there is any. Yes, and you will test both points.
So that's what I was thinking. Like fxx is always going to be either less than or greater than 0.
It can be positive or negative. Yeah.
Yes, but of course that would be different if the point is different.
Yes.
Once you solve the system. That makes sense.
Yes. Once you solve the system and the system gives you 2 points, you will check 2 points. It doesn't necessarily mean that one will be min and one will be max. Maybe one of them is a saddle point and the other one is a min or a max. I don't know. It depends on the function. So I'm looking to see if there is an example that we can look at. No, all these problems have only one possible, if you want, critical number. Yeah, I don't see anything. But that would be, so you're not going to get anything with 2 points, but that would be the only thing. You're gonna get 2 points by solving the system. Once you solve the system and you get 2 points by getting basically the quadratic system
Yeah, I was
or
gonna say,
non-linear system.
so the system, or like the original one would just have to have a degree of 3 for
Yes.
like multiple points to show up,
Yes, yes,
is what I assume.
yes, because then you have to create a system with 2 non-linear equations, or even 1 linear and 1 non-linear. So then potentially to get 2 points. I'm even looking at the examples they presented in the book, and I don't see any with actually I did find one.
Yeah.
I just did example 2 on page 544. Yes. Yep. So this was the function, find the relative max and min values of this function. And because it has an x cubed, you will see down the road you will have 2 possible solutions. One possible solution is 1/6, 1/12 is a critical, potential critical, I mean, it is a critical number and we don't know what it is yet. And 0, 0 is another candidate for a max min because it's another critical point. And they end up saying, oh, no, this is, D is negative. So it's a saddle point for 0, 0. But for the other point, they come up with the fact that the D is positive and also,
fxx is positive for that.
yes, it's negative.
Oh, it's negative for that.
Yeah, it's negative, so that's why it gives a relative max. Very good question. No, I will not. I'm only interested in the mechanism. You don't have to repeat the mechanism twice. I'm only interested in how you show that with 1 point. If you know how to show 1 point, you know how to show the other. Okay, so what we continue with?
So for test 3, the list of problems that you've given us for the study guide, are you gonna be asking for any other skills?
No, only what we covered. Only what we covered in class.
Okay.
Yeah, that's basically it. So, so what we covered last time from chapters 4, 5, and 6. So we look at a problem like this in which we were given the derivative, we're asked to integrate, basically, and just find the function, nothing else. And you were given a condition to approximate the area using 4 subintervals, and the leftmost point or the midpoint or whatever, something.
Can we do one more question?
Yeah. So let's say we have f of x equals, I'm just making it up, the square root of x natural log x, and we want to approximate, let's say, between 2 and 3.
Can we do 2 and 6?
Yeah. 2 and 6. And let's say 4 subintervals. And let's say leftmost point, rightmost point, or midpoint, whichever you want. Rightmost. So in that case, please remember, always try to do this first. Between 2 and 6, 3, 4, 5, 6. So this is 3, this is 4, this is 5. If we want the rightmost point,
6, 5, 4.
we have 3, the height at 3, the height at 4, the height at 5, and the height at 6, because we chose the rightmost point. So the area with right 4 equals delta x, which is 1, times f of 3, plus 1 times f of 4, plus 1 times f of 5, plus 1 times f of 6. Is that clear? So since it's 1, I don't have to repeat it. So I'm going to write f of 3 plus f of 4 plus f of 5 plus f of 6. I will put this in the calculator. So let's go to y equals. I'm sorry, forgive me. Go to stat and go to edit. So go up to list L1 and clear and enter. If you have anything, I do. So I have to go up to L2 and clear and enter. So here I have the list of 3, 4, 5, and 6. 3, 4, 5, and 6. And on the right hand side, highlight the name of L2. And I want to put the function is the square root of x natural log x. Square root of L1 second and 1. So I want the calculator to take every 3, 4, 5, and 6 and take the square root. Make sure you are completely out of the square root.
Wait,
And
how'd you put it up? Oh, okay, never mind, sorry.
That's okay. And to multiply by a natural log of L1. I don't want to do this by hand, so I want the calculator to calculate all these numbers. So this is f of 3. This is f of 4, f of 5, and f of 6. So now I go to get out of there with second and quit, and go to stats, and go to calculations. Oh no, so, let me see, I want something else. I want second and stat. And go to math, and choose number 5. And we want to add up everything that is in which list?
L1,
Careful.
L2.
Exactly. And press enter. So I don't have to do this by hand. It's going to take forever. So the sum is 12.66. So you put your x values in list L1. In list L2 at the top, where it's highlighted, you put in the function. But instead of plugging in x, you plug in list L1. And then you press enter, you get all the numbers, and then you add them up. We can practice one more if you want. Or are we okay with this? Yes, Brian?
And actually, how do I get to the sum function or the?
Go to second and stats, and go to math, and choose sum. But it has to be on list L2 because that's what we have. Now, what if the width of the interval is not 1? Let's say the width of the interval is 2. Then I would have a 2 in front of the function. 2 times the square root of list of L1 times natural log of list L1. I didn't put anything because it was 1. Do we need to illustrate with another example? Yes?
I have a quick question. So
Sure.
if we do another example, I've seen the leftmost point, the rightmost, but what about the middle?
Okay. Okay, let's choose a function.
But I hope if you start from the right or the left, where do you start in the middle?
In the middle. So where is the middle, right? Is it 2.5? Where is the middle at 3.5? Where is the middle at 4.5? So I will have f of 2.5 plus f of 3.5 plus f of 4.5 plus f.5.5. That's all. So let's come up with another function and another interval. Choose a function that you like and give us any interval you like.
Five minus x squared over 3x plus 4.
5 minus x squared over 3x plus 4. And let's say between 10 and 20 with 4 subintervals with a midpoint. So first let's divvy up the interval between 10 and 20. Now I have to find the midpoint. So here I have, right? So I have 12.5. So the middle will be at, so the distance is, it's 2.5, correct? So 2.5 divided by 2 is 1.25. So 11.25 is in the middle. Again, this is 1.25.
13.75.
Correct. And then 11 plus 1.25, 16.25. And then 17.5, right? 18.75. So then I have the area with a midpoint 4. 20 minus 10 divided by 4. That's the width of this interval, right? Which we know is 2.5. 20 minus 10, 10 divided by 4 is 2.5. So now I have 2.5 outside, and then f of 11.25 plus f of 13.75 plus f of 16.25 plus f of 18.75. Of course, this will be a better approximation. The midpoint is always a better approximation of the actual area. Okay, so we go to the calculator. What do I put in list L1?
11.25.
Right, but we have perfect, but don't forget to go in and clear. Clear list L1, clear list L2. So in list L1, as you said, I put in 11.25 and then 13.75 and then 16.25 and the last one 18.75. Now let's highlight at the top list L2. Now we have to put in the whole thing. We're going to put in 2.5 multiplied by, the function is, now be very careful, we need parentheses around the top. So I have 5 minus the list L1 squared, close the parenthesis, divide by, open the parenthesis, 3 times list L1 and plus 4. When you click enter, it will give us, one more time, look here for a second, it will give us, the first number will be 2.5 times this number. The second number will be 2.5 times this number, because we already incorporated 2.5. Ready? We didn't do it before because it was 1. So press enter, you will get all these numbers. And now we have to go to stat with second and get out of there with second and quit. And then go to second and list all the way to math and select number 5. I selected number 5 and now I want list L2. Second and 2. And press enter. So the sum, so it appears that this function is under the x-axis. So it's negative 44.8777. So that is the area between the graph of the function and the x-axis between 10 and 20. So it appears that the function is under the x-axis because the area is negative. So if we want to check that, and let's look at y equals, in parentheses for the top. You don't have to do this, I'm just curious now. Because this is Maddie's baby. She came up with it. So 3x plus 4. Close the parenthesis. And I want to graph this, of course, only between 10 and 20. So I'm going to say negative 4 is good enough. But I definitely want to go, as you see, it's right here, right? I definitely want to see 25. And I want to see the negative side, of course, because I have to see a negative function. I mean the function under the x-axis. So y minimum, I'm going to put in negative maybe 40 to positive 10 with a scale of 10. That's all I want. I want to see between.
Did you put, yeah, you want negative 40 or negative 4? For me.
Yes, thank you. Negative 40 to 10 with a scale of 10, and I want between 10 and 20, so negative 4 to, okay. So I need to see a function that is between negative 10 and positive 20, and a function below the x-axis. So I don't know where 10 is, but 20 is somewhere here. So everything is under the x-axis. Or the area is bigger under the x-axis than it would have been above the x-axis because I got a negative number. Function is below the x-axis. Thank you, Matt. It was very interesting. Good. So we have this set up. Okay. Which other type of problem we should look at? Anything else that you would like to go back to?
Are there any anti-derivatives that you think might be difficult?
No, no, absolutely not.
On test 3, can we do one similar to 3? We don't have to graph it, but it's just finding the areas to,
Enclosed,
yeah.
very good. So, okay, on page, it is section 4.3. Page. Page 413, that's where the examples, more interesting examples are. Page 413. Yeah, let's look at, unless we did 22, did we do 22, x squared and the square root of x?
No,
Yes, we did.
no, we didn't.
Okay, so 22 on page 413.
We do y equals x squared minus 2x and then y equals x.
Okay, so we have y equals x squared and y equals the square root of x. Perfect. Very good example. I mean the type of problem that you selected. Good, so I have to graph, find the points of intersection. So when I graph x squared, we have no difficulties when x is 1, y is 1. When x is negative 1, y is 1. So this is the graph of x squared. Now I know how to graph the square root of x. When x is 0, y is 0. When x is 1, y is 1. So it's really nice because I really don't have to determine the points of intersection. So we're asked to find the area enclosed by these two graphs. And we know that it must be between 0 and 1. So this is the area in question between 0 and 1. So the area will be the integral from 0 to 1 from the top function of the area, which is,
X squared root of X.
very good, minus the bottom function of the area.
X squared.
That's it. Now, if you get a negative answer, then you know you don't have it in the correct order. Good. So we know the antiderivative of the square root of x because this is x is to 1/2. I increase the power and divide by the same number. X to 3/2 over 3/2 minus x cubed over 3 from 0 to 1. All I have to do is just plug in 1 and flip 2/3. So 2/3 minus 1/3 equals 1/3. So the area under the graph, I'm sorry,